When we're computing reliability, we have a couple of different situations. The first situation is similar to problem number 1 at the back of chapter 5, where you have different parts in a system, and in this case, you've got different reliabilities in each component part. So for this first problem, we've got a reliability in component part 1 of 0.8 or 80%. The reliability in component part 2 is 0.98 or 98%. So in order to find the reliability of the system, it's very easy. You just multiply the two together, or we can use the product function. So the product of these two, it's used similar to the sum function. Product equals product, and then you just select the range. So the reliability of this system functioning with these two reliabilities is 78% of the time. So if these are the reliabilities of the two parts, then this system is likely to function 78% of the time. Okay. Now, if you've got component parts in a system that all have the same reliability, so let's say that they're all 96% reliable or 0.96, and you have 5 components in the system. This is also very easy. You would just do a equal sign. We're going to raise the 96 to the 5th power. That's just much easier than you doing 96 times 96 times 96 and so on and so forth. So we would just do 96 raised to the 5th, and in order to do that, you're using your little caret here. That's the power symbol. And so this system would be 82% reliable. Now let's say we wanted this system to be 90% reliable. What would our component need to be here in order for the system to be 90% reliable? In order to solve that problem, we need to use what we call the goal-seek function. The goal-seek function allows us to know the result of a formula and to find out what one of the parts of the formula must be. So we went to data and we went to what if analysis. So data, what if analysis, and we chose goal seek. And we're going to set this value to 0.90. So we're setting our resulting value to the value that we want to find by changing the value of the part. Okay, and we're going to click OK, and it came out with a 0.97.9 or 97.9% reliable. So it would have to be almost 98% reliable, each component part, in order for the system to be 90% reliable. Okay, so that's how you compute that. Now, the only other part that we have to do is, usually though, in a system, you might have a part with a backup part. So for example, think of your alarm clock, for example. A lot of times alarm clocks will plug in, but they also have a battery backup. So that's in case your electricity goes out in the middle of the night. I'm sure that you've witnessed like a surge of electricity during the middle of the night, and you wake up and your alarm clock is flashing because perhaps you don't have the batteries put into the alarm clock. The batteries are there to serve as a backup in case that happens, so that your alarm clock doesn't lose power. So the reliability of the system then would be more reliable than if you just had the electricity on its own. So what we want to take a look at now is how to calculate that system in the case that you have a reliable part with a backup part. So we have part 1 and we have part 2, and this is problem number 2 on the end problems, and this is This is the main, and this is the backup. Okay, so this is going to be 0.80, and this is 0.80. And the backup system is... Okay, and then our backup here, this is supposed to be 0.98, and then our backup over here is 0.80. Okay, so the first thing that we have to do is we have to calculate the reliability of this system with the 0.8 and the 0.8. So think of it this way. Okay, so if your main system is working 80% of the time, then you only have to use your backup for 20% of the time. So you're going to take your 80% of the time, so your 80% reliability, and then you're going to add to that the reliability of the second part, which is 80% times having to use that for 20% of the time. So 80% times 20% of the time. Okay, so you're having to use the second part only 20% of the time. So you're going to add that to the other 80%, and that's going to tell you the reliability of this system. Okay, so the whole resulting system from the main and the backup is 96% reliable. Okay, so you've got now 96 and then you have 98%. So now you've got your two pieces of the system, and you can go back to how we solved this problem up here. So we're going to do equals and product. Choose our two values here. And so our whole system, therefore, is reliable at 94.08 or 0.9408. And that's it. That's how you work these problems.